Triangles, one of the study elements in your exam. Now, before we dive into question, I want to just point out one thing. So let's say we have a triangle and a triangle. When I'm thinking about triangle, when I'm describing the triangle, what am I going to talk about? Well, I'm going to talk about the length of each side. So I'm going to talk about the sides. And what is the other aspect about triangle is the size of the angles inside. So when you are thinking about triangle, we really think about those two aspects, the length of the sides and the angles inside. Okay, let's see. A roof is in the shape of a square base pyramid as shown. So square at the bottom here. The square base ABC has a side of length 6 meters. 6 meters, so that's 6 here, that's 6 here. The diagonals of ABCD, so that means the diagonal of the square. So I have a square, and then here I have the diagonals. Here is 6, here is 6. And they meet at the point A. And then the top of the pyramid is directly above O. That means that here it's creating the right angle. The four triangular faces are congruent, mean they are the same. The faces, that side here, they are the same. And then we are told that AP and BP, so both of those lengths are 11. Then this side we know is 6. Well, that as well make isosceles triangle. That means that both of those angles are the same. So what do we need to do with this information? Use the theorem of Pythagoras. So look at that. They're very kind to tell us what to use to show that OB is 3.2, and hence, so with that knowledge, with using OB, we will be able to find the value of OP, the vertical height of the pyramid. So let's see, how do we find OB? So my OB that is here, it's a part of two things. It's a part of this triangle here, and as well OB is a part of the base of the square. Now, what am I going to use in order to solve it? So I'm saying, okay, if I consider both of those concepts, so I have OBP, and then I have A, B, C, D, and then my OB is, oh, that's a little bit not straight. OB, so this is the part, this is the part. So what do I know about it? So like we said, those lengths here are 11. Okay, but I don't know PO. Actually, PO is something I need to find, and I'm going to find second after I find OB. But here, when I'm thinking about that is 6, well, that create right angle triangle in here. So there it is. I can find my OB I'm looking for. So that means that's the reason why they say use Pythagoras, because Pythagoras, we have the right angle triangle here. Now, Pythagoras, c to the power of 2 equal a to the power of 2 plus b to the power of 2. I need to know what is c, a, and b. Well, c is the side that is opposite the right angle, so that side, db, will be c, and then one a, one b, doesn't matter which one is which one. So let's replace those with numbers. So here, that part, it's OB I'm looking for, so that OB multiplied by 2, that will be the full length of C, so that will be taken to the power of 2, and then A being 6, and then B being 6. So first we eliminate power of 2, so that means we have a square root of the other side, and then the next thing, let me just move that. And then the last part to do is to eliminate that 2, meaning divide both sides by 2 to eliminate multiplication. And we put that in the calculator, and indeed we are getting 3 square root of 2. So first part is found. Now the second part to find that PO. So now since I know that this is 3 square root of 2, I can find this missing part here. Again, right angle triangle with that being C. Let's say that's A, that's B, doesn't matter. So when I'm looking for value, what happened here? For value of A, I move my B to the other side, change the sign, and I don't want the power of 2, so I take a square root of the other side. So that means my C is 11 to the power of 2 minus B, which now I know is 3 square root of 2, and that is taken to the power of 2. And when I put that in the calculator, I get that that length is square root of 103, and I should leave it in that form, they are telling me. Okay, let's have a look at next part of this question. On the triangular face PAB, so that's what we were saying, that triangular face PAB, that's 11, and that's 6. The size of angle PAB, so this one, is 74.2. Now we know that this will be the same, 74.2, because it's isosceles triangle. Use these or otherwise to work out the total area of the 4 triangular faces. So the area of that triangle multiplied by 4. How do we find area of triangle? We go to our maths tables, page not 16, page 9. Here we have 3 different formulas for the area of triangle. Which one do we pick? The one we have the information for. So let's just take that and let's consider which one will be the most useful to us here. So the first formula, that has to do with what? A half multiplied by a, which is the base, and then multiplied by a, which is the height. Do I have the base? Yes, I do, any of them. But then I don't have a height. Could I find it? Yes, but let's still keep on going and see maybe a different formula will not need additional calculation. So again, the next one, half multiplied by a, which is one side, multiplied by b, which is the second side, multiplied by sine of angle C. So this one needs 2 sides and an angle. Do I have that? Yes. Let's say, for example, this side, and this angle. So here we don't have to do additional calculations. So we are saying a half multiplied by a, let's say that be 6, doesn't matter, a or b, because we are multiplying them. Then b, let it be 11 multiplied by sine of my angle, which is 74.2, and then multiplied by 4 because there is 4 of those faces. And then we put all of that in the calculator, we press equal, and to the nearest meter, 127 meters to the power of 2. Really nice calculation. Now, the next part of this question, a little bit unusual for higher level, but here it was. The diagram below shows part of a scaled diagram of the net of this pyramid. The diagram shows the square base, the 2 of the triangular sides. So we can see that we have the base and triangular sides. What do we need to do? Construct the rest of the scaled diagram of the net of the pyramid. Show all your construction lines clearly. So what am I missing? Another 2 sides. Where do you draw them? Wherever you want. Now, the main part here is about that they have to be exactly like this triangle. So how do we do that? We take our compass, that's not what I wanted to do. We measure the exact length that we have here, and then we use that from whichever face you want. Let's say from this side, we draw an arch without changing. Then we go to the other side, we draw an arch because it is an isosceles triangle. Both sides are exactly the same. Then we take a straight edge and we just join the join one part with where it meets. So that's okay, hold on, my apologies, it moved, so I need to do it again, and then again on the other side, joining that place where it where the 2 arches meet. Now it's more difficult for me to do it on this equipment, but it's so much easier for you to do that with the pen and paper. And we join and we have that. And then let's say we do the same thing on any side, can be here or can be here, depending how where it is more convenient for you. Let's say we're going to do it. Let's say we're going to do it from this side. So again, we place it, we do the arch, and then on the other side, we do a second. And again, we just join the lines. Now, mine is not perfect, but I'm sure yours will be perfect. It's a little bit more difficult to be precise on the screen with that equipment. So that's it. And we have the net. Nothing more than that, really.